representing the resale value of a car X years since it was purchased. So this is a problem we went over in class where we are looking at how we can use these linear graphs to make predictions and to use our knowledge of the y-intercept and of slope to write equations and answer questions. So let's first get grounded in the graph. So we have our x-axis running along right there in the blue, and that represents the number of years since purchase of car. Again, that is our x-axis. And then we have our y-axis going vertically. And all the numbers along our y-axis are the resale value of this car. So again, in green, that is our y-axis. And what we can notice is that as our years increase, as our years increase, our y values are decreasing. So as our x's increase, our y values are decreasing. And from that, we know that we are working with a negative slope. So speaking of slope, this first question says, what is the slope of this graph? And what does the slope of this graph represent? So in class, we looked at the fact that slope is often in word problems or in the kinds of graphs we see used in every day. Our slope will be our rate of change or our unit rate. As our y's change, what's happening to our x? Let's remember that we always calculate slope by looking at our change in y divided by our change in x. That is what those little triangles mean. That is the Greek delta, and it means change. And so in this case, if our y values are the resale value, for this, that's going to mean the resale value per year since purchase. So when we find the slope, that will tell us the resale value per year since purchase. Let's do this calculation. So we need to pick 2 points that are exactly on this grid. So again, we have a scale here, our x scale. So I'm going to write this down. Our x scale is 1.5. Let's go ahead and write down our y scale too. Our y scale is increasing by 5,000. Okay. That'll come into play in a second. And I want to pick a couple of points that are exactly on the coordinate grid where I'm working with integers. I have nice clean data points to work with. So I'm going to pick this point where x is 0 and y is 20,000. And then I'm going to pick this point down here where x is 6 and y is 5,000. And again, I picked those points because it's going to provide me with some really clean data. Now let's go ahead and calculate our slope. I'm going to start from my bottom point and calculate my change in y. So from my bottom point to my top point, I move up 1, up 2, up 3. So when we're working with a scale of 1, that would give us a numerator of 3, positive 3. But our scale on our y-axis is increasing by 5,000 every unit, which means that I did not go up 3, but I went up 5,000, and then I went up another 5,000, and then I went up another 5,000. So in this case, my change in y was not 3, but my change in y was 15,000. Now I can do my change in x. So I'm going to be moving to the left 1, to the left 2, to the left 3, and to the left 4. So again, if my scale was just by 1, then that would be a denominator of -4, or change in x of -4. But my x scale is 1.5. So I actually lost 1.5 there, and then another -0.5, and another -1.5, and another -1.5. So in total, my change was actually -6. My change in x was -6. And then I can simplify this ratio. Positive 15,000 divided by -6 is -2,500. That means that my m in y equals mx plus b is going to be -2,500. And what this means is that my resale value drops $2,500 every year since purchase. So I could write a quick sentence about that in terms of what does this mean. That means every year after purchase, the car loses $2,500 in value. Sorry, I kind of ran out of space there. Every year after purchase, the car loses $2,500 in value. That is what our slope means. I am going to just highlight where we wrote our m here, though, because we're going to need that for our equation. So our m is -2,500. Next, let's look at what our y-intercept of this graph is and what that represents. So I'm going to erase some of this scribble I have here. Okay. Our y-intercept. Again, the y-intercept is where the line of our graph crosses our y-axis and where x equals 0. So here's my y-axis. Here's where my line crosses that point. So my y-intercept. And that is the point where x is 0 and y is 20,000. Which means that for y equals mx plus b, b is just the y coordinate. So my b is going to be 20,000. And our y-intercept is typically the starting point. So in this case, that's definitely perfect. We can think of our y-intercept as the starting point. So when x is 0, where x is our number of years, so when 0 years have passed since purchase, meaning the day this car was purchased, our y is 20,000, which means that on that day, the car was $20,000. So on day 0, the car was $20,000. Okay. And now we can write an equation. We have our m, we have our b. Let me highlight that b. And we can write an equation. So when we are writing these equations, we are working with slope-intercept form, which is y equals mx plus b, where m is our slope and b is our y-intercept. So for this graph, y equals, our slope was negative 2,500, x plus our y-intercept. And that y-intercept was 20,000. And that is our equation. We could plug any value of x in, x being the number of years since purchased. We could plug any value of x into this equation, and what we'll get out is the y, or the resale value, at that current moment in time. So I'm asking you to write a sentence to explain the equation in terms of the problem. For here, I frequently like to work backwards because that y-intercept is often the starting point. So I might say a $20,000 car loses $2,500 in value each year after purchase. And all of my elements are there. I have my slope represented, negative 2,500, loses 2,500. I have my y-intercept represented, the $20,000 car. I'm showing my x. My x means number of years each year. And my y, which is my resale value, represented right there. So my whole equation is a sentence. A $20,000 car loses $2,500 in value each year after purchase.